Welcome back. Hope you enjoyed your little break. In this one, we're going to look at what a p-value is. Never heard of that before, right? And then we're going to look at how to interpret a p-value. All right, so a p-value of a test is the probability of getting evidence for the alternative hypothesis as strong or stronger than the observed evidence when the null hypothesis is true. Now that seems like, wait, what? There's a lot of information there. All right, so let's try and state this in a different way. What is a p-value? A p-value is the probability of getting our particular sample statistic or farther away from the mean, the true mean or proportion. We'll put the word true in here. True mean or proportion, given that the parameter is true. So the null hypothesis is true. So it's easier to think of the graph. So if we have some sort of null hypothesis, and let's work with mean because usually mean is easier. Mean is equal to some number. I don't know. Let's just say 100. So right here in the middle is our mean is 100. All right, and our alternative maybe is that the mean is greater than 100. So say we take a sample, x bar, and we get that our sample mean is 110. And maybe 110 is right here. All right, so this is a sampling distribution right here. Let me just remind you, sampling distribution, G. All right, everything we work with in this semester basically is a sampling distribution. So this sample, the probability that it's this far away or farther away is this area out here. And this area is what we are calling our p-value. So it has nothing to do with like the true proportion or any of that sort of stuff. I'm using capital P here instead of a lowercase p. It is the probability of getting this far away, the sample that we got, or farther away. Like it's this area that just keeps going. And if this area is really small, then we say, so if P is low, we reject the hoe. So if P is low, reject the hoe. In other words, we have evidence that the actual mean is greater than 100. So we think that this guy is probably wrong. Like if it was close to 100, then yeah, then we'd say, okay, yeah, it's probably close to 100. But if P ends up being really small, that means the sample we got is really far away, and we want to reject the null hypothesis. All right, now, if it's the other way around, so let's try a different color here. Let's switch over to green. Let's say I took a mean and I got 102, and it's like right here. All right, so then the p-value would be from here all the way on out. All right, and this was 102. All right, this would be a pretty big p-value. All right, there's a lot of area here. All right, if there's a lot of area there, that means that this x bar is close to what our null hypothesis was. It's close to this. So if it's close to what our null hypothesis is, that means our null hypothesis was probably correct. So if P is high, the hoe is fly, is what I like to say. We don't reject fly hoes in this class, guys. So if P is low, we reject that hoe. Right? If P is high, the hoe is fly. Don't reject the hoe. All right? I'm still trying to come up with something here. I try something different every year. If you can come up with something better, more power to you. P is low, reject the hoe. That one works out real well. P is high, we don't have a good one, but the hoe is fly. That's what I'm going with this time. All right, so low usually means less than 5% or less than 10%, but this is a number that will be given to us prior to starting the experiment. And we usually call this number alpha. So like we'll say alpha equals 0.05, or alpha equals 0.01, or alpha equals 10%. Like they'll tell you ahead of time. It'll be stated in the question. If it is not stated, then just go with the 5%. 1 in 20 is what 5% is. All right, so let's take a look here. So calcium is a vital nutrient for healthy bones and teeth. I think we've all heard that before. You remember, drink your milk. The National Institutes of Health, or NIH, recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that the teenagers aren't getting enough calcium on average. Is this true? Researchers decided to perform a test of the null hypothesis is that the mean is the 1,300 milligrams of calcium. Ca, I believe, is the chemical formula. All right, our alternative then would be that the mean is less than this 1,300 milligrams of calcium. All right, because we think that they aren't getting enough. All right, so that would be less than. All right, where mu is the true mean daily calcium intake in the population of teenagers. They ask a random sample of 20 teens to record their food and drink consumption for one day. They then compute the calcium intake for each student. Data analysis reveals that the sample mean, X bar, is 1,198 milligrams with a sample standard deviation of 411 milligrams of calcium. Researchers performed a significance test and obtained a p-value of 0.1404. Explain what it would mean for the null hypothesis to be true. All right, well, our null hypothesis is that the mean is 1,300. In other words, what that would mean is the true mean, and I'm going to go ahead and state context, true mean calcium intake by teenagers is not significantly different from 1,300 milligrams. All right, so if this was true, this null hypothesis is true, that means the true mean, the population mean calcium intake by teenagers is not significantly different from this 1,300. It's pretty close to that 1,300. All right, next, interpret the p-value. All right, so we're below the mean here, right? So if we have a graph, and let's say we've got a normal sampling distribution here with a mean of the 1,300. Our mean is this. It's somewhere down below it here, our X bar, this 1,198. And that means that this area here, that's the p-value, is 0.14, I said 4, I wrote 3, 1404. That's our p-value. All right, so that's what it means in a graph. So what does it mean in words? It means that, so that would be 14%, roughly 14%. 14% of all samples of the same size, in this case it was 20, will have means at or below, because we're going less than, 1,198 milligrams of calcium. All right, that's what that means. That's what that 0.14, or we can say it has a probability of being below the mean of 0.1404. All right, so there's 14% down here that are this far away. 14% is a high number. All right, so we would not reject the HO. All right, it's above usually what we use for alpha, but we're not given any alpha yet. We're just talking about what's happening here. All right, so now this is how we go about making conclusions. So if the p-value is small, then that means we have evidence against the null hypothesis. So p small means we have evidence against the null hypothesis, not for it, against it. There is a small chance of getting the results that we observed if the null hypothesis is true. Therefore, we conclude to reject the null hypothesis. All right, now I know sometimes in your AP Bio class, your teacher tells you to accept. We never accept anything. All right, our two options are either reject the null hypothesis or fail to reject the null hypothesis. We are not ever rejecting anything. All right, so before I go to the examples here, significance level. So the value alpha, remember this is alpha, that we use as a boundary for deciding whether an observed result is unlikely to happen by chance alone when the null hypothesis is true. All right, so we have some sort of graph, and at some point we hit this area to be the same as alpha, and if we end up in this area, sometimes we call this the rejection region. And this would be the, over here on this side would be fail to reject. All right, and this is some sort of critical value right here. All right, so if our p-value is less than alpha, we reject the hoe. We have convincing evidence for the alternative hypothesis, and we state that in context. So this is basically what we're going to state. If the p-value is greater than or equal to alpha, all right, we include the equal to. It'll never be equal on the AP exam, don't worry. But if the p-value is greater than alpha, we fail to reject. We do not have convincing evidence for the alternative hypothesis. Right, so a company has developed new AAA batteries that is a new AAA battery that is supposed to last longer than the old AAA battery. The company knows that its old batteries last for 30 hours of continuous use on average. The company selects a simple random sample of 15 new AAA batteries and uses them continuously until they are completely drained. The sample mean is 33.93 hours. A significance test is performed using these hypotheses. Our null hypothesis is that it's equal to 30, because that's what we started off believing, 30. Our alternative is we want to know, are these new ones better? All right, so we want to know, do they last longer? That means greater than, where mu is the true mean lifetime in hours of the new batteries. The resulting p-value is 0.0717. What conclusion would you make at the alpha equals 5% significant level? All right, so at 5%, we would say that our p-value equal to 0.0717 is greater than our alpha, which is 0.05. All right, so that means it's not low. So that means we fail to reject HO. And our hoe we're just going to write is that it's equal to 30 hours. All right, so that means we do not have significant evidence for the alternative. And the alternative is that the true mean is greater than 30 hours. All right, we can say true mean battery life if we want. There we go. All right, what about at the 10% level? So our p-value, again, was equal to 0.0717, which in this case would be less than the 0.10, which is equal to alpha. All right, so that means p is lower than our alpha. P is low, that means we reject the hoe. So we are now rejecting that the mean equals 30 hours. So if we're rejecting this, that means we have significant evidence for this guy, for the alternative. So we have significant evidence. That the true mean battery, trying to make sure I have context here, battery life is greater than 30 hours. So there's my context. I'm basically stating the alternative hypothesis. All right, so example, one more here. So the p-value for significance test is 0.15. So my p-value equals 0.15. And the significance level alpha is 0.05. Well, that's greater than 0.05, which is alpha. What is the correct conclusion? All right, so p is high. That means the hoe is fly. We don't reject the hoe. So we fail to reject the hoe. All right, so let's see, accept the hoe. No, we don't ever accept anything. I'm going to get rid of the ones that say accept. Reject the hoe. No, we are failing to reject. Reject the ha. No, not necessarily. Well, maybe. Fail to reject the hoe. Fail to reject the hoe. Yep, that's something that we can actually do. And fail to reject the ha. Nope. All right, so we fail to reject the hoe, which means we have significant evidence for the hoe. All right? It doesn't mean we reject the ha necessarily. We're just failing to reject the hoe. All right, so that's it for that. And the next one we'll come back and look at types of errors that we can make.